Okay, today we're going to talk about systems of linear equations. And for your homework tonight, you're going to need graph paper. Okay. Now, when we say systems of linear equation, it sounds pretty kind of complicated. It turns out it isn't. You guys remember linear equations? When you graph linear equations, what do you get? You get a line. Okay. So when we say systems, it means simply having many equations. That's all. Okay. So just more than one. If you have more than one linear equations, that's what systems of linear equations are. Okay. That's it. If you have more than one linear equation. Okay. So let me give you one linear equation, and as a matter of fact, I'm going to graph it for you. Here we go. The reason why I'm graphing it is because today's method to solve the system, we're going to show you how to solve systems. We're going to use this method called graphing method. Guess what graphing method involves? Graphing. Okay, so let me graph this line for you. Hold on. All right, so let's graph a line. Somebody give me an equation of a line in slope-intercept form, because isn't that the easiest way to graph? Okay, so yes, give me an equation of a line. Y equals to 2x plus 8. Do something slower so I can see the y-intercept. 2? 2 is fine. Okay, 2. Here we go. All right, so we got a line. Y equals to 2x plus... Let's do 3 because there's too many 2's. Okay, 2x plus 3. Is that okay? So is that a systems of linear equation? No. Systems is when you have more than one line, right? More than one equation. Well, before I get to the second equation, by the way, if I say more than one equation, how many equations can a system have? Yeah, as many as you want. You could have 2, 3, 4, 10, million, 1,000, whatever. Okay, but we're going to talk about the simplest case. Guess how many equations would it have?
1.
No, if you have 1, is that a system? No. Okay, how many? 2. So we're going to talk about the simplest. All right, so by the way, what are all the points on this line represent? What do all the points on this line represent? By the way, how many points are there on this line? Infinitely many. What do all these points on this line represent? Tajwar? Solution to this equation. You guys remember? And if you were to plot all this solution, it turns out to be a line. That's why we call this equation linear equation. Do you guys remember this? Yeah? So pick any point, like 0, this one is the easiest one, 0, 3, look, even it gives 0, 3. When you plug in 0, 3 to this equation, the left side will equal to the right side, right? It becomes true. What about if I plug in 1, 5? What do you guys think? The left side will equal to the right side. Every point on this line is a what? Solution to this equation. Is that okay? Now, let me graph another line. Somebody give me another line. Y equals to, Matthew? 4x plus 2? Plus 2. All right. 2 is good. Okay, let's make that to something else. How about 1? There you go. Is that okay? Can I just skip? Because I did that on purpose. Anyway, so take a look at that second line. This purple line. How many points are on this purple line? Infinitely many. And that's a solution to the second equation. Right? Now, I claim to you, you should be able to see the solution to this system. What do you think solution to the system means? It's got to be a solution for both of these, right? Not only one of them, right? Do you see a solution that's going to be a solution for both of them? You should all be able to see it. Okay, everybody discuss with your group. I'll give you time. What do you guys think? Okay. All right, so how many people think they know the solution to this system? Now, when we say system, we're talking about both of them together, right? We want a solution that's going to be solution for both. Sammy?
Isn't it the point where they intersect?
How many people agree with Sammy? She says, isn't it the point where they intersect? Very good. You guys are correct.
Yeah.
Okay, which is what? What is this point? 1, 5. Why is 1, 5 the solution for this system? Why is it the intersection? Why is the intersection the system? Jason?
Because if you plug them in, both of them it works.
Yeah. Because you could think about that. Yes, if you plug in 1, 5 to both of them, it'll work, right? But you can see this graphically. Why 1, 5? How come, like, why wouldn't 0, 1 work? Isn't 0, 1 a solution?
Because they don't.
Yeah, but 0, 1 is solution for which one only?
It's not in the other line.
Yeah, it's only a solution for the second one, not the first one, right? 0, 3 is only solution for the first equation, not the second. But where they intersect, right? They share that point, right? So therefore that point is the solution for both of them. So it turns out if you have systems, right, of linear equations, where the two lines intersect, that's your solution. Does that make sense? Because 1, 5 will be true for the first equation. Not only that, but it will be true for the second equation also. So whenever you have two lines, when they intersect, guess what? That is your solution. And on tonight's homework, well, not tonight, tomorrow's night's homework, it's going to ask you to find the solution of systems of linear equations. And which method are they going to ask you to do it in? This method is called graphing method. Why do you think it's called graphing method? Because you graph. When you graph them, do you see why I said you want to graph this in a graph paper? Why don't we just do it on? Why is it important to do it on a graph paper? Yes. Yeah, and not only that, it'll be more accurate. If you were to just make your own like units, it's not going to be really accurate as graph paper. Does that make sense? Are you okay with that, guys? Now, so let me ask you this. When will you get, by the way, do you think they're going to give you these systems of linear equation in slope-intercept form? They won't.
Not all the time.
Not all the time. But if they don't give it to you, Dana, how are you going to graph it? Yeah, you change it to, if they don't give it to you in a slope-intercept form, you rewrite it in slope-intercept form, because isn't that the easiest way to graph? Right, guys? All right. Now, let me ask then, will you always get solution to systems linear?
No.
There will be times when the systems linear equation would not have any solution. When would you not get any solution? Everybody think about it as a group, because there are times when you won't get any solution. So, who thinks they know when we won't get any solution when you have systems linear equation? Chuck.
When two lines are parallel.
When the two lines are parallel. Eric, why? Do you agree with him?
Yeah.
Why would you not get any solution when the two lines are parallel?
Because it will equal to 0.
What will equal to 0?
The x or the y.
No.
Oh,
When the slope is 0, you get a horizontal line. Yes, Eric, you want to?
they will never touch each other.
Yeah, they won't touch. They won't intersect. So how can I change? Okay, let's change the second one. How do I change the second one so that they don't intersect? What can I do? Change that slope to 3. What is the slope of the first line, class?
2.
And if the two lines are parallel, what do you know about their slope? So Michael, what should I change that to? 2. Look what happens when I do. You get two parallel lines. They're not going to intersect. What are you going to write when you graph these two lines? You get no solution. Does that make sense? Not undefined. Undefined means it doesn't exist. I mean, the number doesn't exist. Here, you don't have any solution, so there's no solution to it. Now, let me ask you this. There's a time when you get infinitely many solutions when you have systems of linear equation. Anybody see when when that would happen? Aiden.
When they're like the same one.
When the two lines are the same lines, exactly. When one of the line is squiggly, then it's a curve. It's not a line. Okay, so you can't do that. So therefore, yes. How do I make then the second? What can I change in the second line so that you have infinitely many solutions? Yes, Carolyn.
Change the 1 to 3.
Yeah, change the 1 to 3. Then you get the same exact line right there. So they're intersecting everywhere, right? It's the line is on top of the other. So if you get this line, what do you get? That's your solution? Infinitely many. Does that make sense?
Is that what you write?
Yes, that's what you write. Infinitely many solution. Now, let me ask you this. Does infinitely many solution mean any order pair? No. Like 0, 0. Is that a solution? No, we don't mean any order pair. Which order pairs are we talking about?
Everything on the line.
Everything on the line. Does that make sense? Like, for example, 0, 1 or 1, 5 and things like that, right? Any point on that line will be your solution because both of the lines are exactly the same line. Is that right? You have the same slope and same y-intercept. So there are 3 cases. What's the first case? You get how many solutions? 1. Yeah, can you get 2 solutions for 2 linear? When you have a line? No. You either get 1 solution when the 2 lines intersect, it intersects in 1 point, does it not? Unless they're the same exact 2 lines and they intersect. So we get 1 solution when the 2 lines intersect, right? Of course, the 2 lines on the same line. What's the second case? You get no solution when they're parallel, and you get infinitely many solution when the 2 lines are the same. Does that make sense? Okay. Can you do something like this for your homework tonight? Good. No?
Tomorrow night.
I mean, tomorrow night's homework. Can you do something like this for your tomorrow night's homework? Does that make sense? Good.